Wasn't Sarah to come today for the code review?
She should be here any moment.
Oh, there she is. Welcome, Sarah.
Hi there.
It's good to see you.
Thanks for the invitation. I am sorry to be a little late.
Never mind. You are new in our team, and you just committed to our code base. We were just reviewing your changes. We found a few interesting things. May I show them to you?
Yes, of course.
Great. Just follow me to this table.
Hi, Sarah.
Hi, guys.
Hi, Sarah.
Hi, Sarah. We were already awaiting you. You will be stunned by what you see.
What you see here on this table is a so-called code city.
Looks cool.
Do you know code cities?
I have heard you mentioning them.
Could anyone tell Sarah more about code cities?
Suzanne is the expert on this.
Okay, fine. Let me explain. What you see in front of you is actually a visualization of the program you just contributed to.
Okay.
Each block here represents a method of your program, including those you changed and added. The height of a block represents the size of a method in terms of its lines of code. The ground area is proportional to a coupling metric.
Does this mean the higher a block, the more lines of code the method has? And the more often this method is called or is calling other methods, the larger its ground area?
Right.
And not to forget the color. Green means that the test coverage of a method is 100%, while red means it wasn't tested at all.
Oh well, there are quite a few red ones.
Not just a few.
You can also see the new and changed methods. The new ones have this green antenna, while changed methods are marked with a yellow antenna.
I understand. So this big and red block there marked by a green antenna is a new large, but untested method.
This is interesting. Can we take a closer look? We want all large and complex methods be well tested.
The name of this method is write Boolean array. That's one of yours. Do you want to see its source code?
Yes, of course.
Fine. Here you see the source code. It is part of the class SuperCompact data output. It looks rather complicated. Well, I must admit that I don't understand it. Wow, I am impressed. You must be a genius. But I am asking myself why this method is not tested. The block is red.
Good question indeed.
Where is this method called from?
Here in the methods marked by a yellow antenna. These are existing methods where I added the call.
Okay, let's take a look at the code diff.
It's so useful that we have the link to the source code.
Nice.
The green line was added. You added a new field, SuperCompact. And you added this constructor call. But your constructor is called only if the field SuperCompact is true.
That was my intention.
Oh well, it is initialized as false. No wonder that your method is not called.
Oh yes, true. I wonder how this has gone unnoticed. At the level of source code, I can't see the forest for the trees.
I guess we need to revise our tests.
I agree.
Great that we could spot this problem in the code city. Code cities can do even more. Are you interested in another kind of code city?
With pleasure. You made me curious.
So let's walk to this other table over there.
Okay, what can I see here?
On the left-hand side you see again a code city for a program. The program implements a compiler written in C. The blocks represent source code files. On the right-hand side you can see another code city. But this time it does not represent the result of a static program analysis. It is in fact an architecture model crafted manually by a software architect. It is very much like a package diagram in the unified modeling language. The edges between the green area represent the dependencies among the architecture component as expected by the architect. A compiler has a main component controlling all other components. It is implemented by these source files. A core of a compiler is typically separated into a front end, middle end, and a back end.
I see.
The front end analyzes the input program. This part is implemented by this bunch of files. Now you may have noticed that this yellow edge turned into a green one. Yellow means expected but not yet confirmed. Green means there are indeed expected dependencies in the code. The middle end runs the semantic analysis, that is, checks whether all entities are declared and all type rules in C hold. This large part of the implementation forms the middle end. Then there is a back end that generates the code which is implemented by these files here. Watch how the yellow edges turned into green ones again.
Oh, this looks good. Why are they so shiny?
Whenever I move implementation blocks onto architecture components, an automated incremental analysis computes edges that need to be updated. The most recently updated edges are drawn with this highlighting effect. The last set of files implement generic, reusable functions. The architecture component common is intended for that. So let's move them there.
Oops, now we have red edges.
Red edges mean that there are dependencies in the implementation that were not expected in the architecture. That is, these dependencies violate the architectural design.
That shouldn't be the case, I guess.
Indeed. We may need to refactor the code or maybe should update our architecture model.
This looks like a very nice use case for Code Cities. It's so intuitive.
I don't think anyone would have spotted these problems if developers are looking only at the source code. If you want to learn more about the development history of the program you are working on, then follow me to this table here.
Most certainly.
Here we see a replay of the development history of our program from its early days until today. A green antenna marks a new file again. When I press this button, the development history gets animated. Each step shows one revision of our program. The blocks represent source code files. Their size is proportional to the lines of code of these files. Newly added files fall from the sky. Deleted files raise to the sky and disappear. To fit all blocks on the table, nodes may need to be moved. Their movement is animated so that you can track where they move. The color gradient from white to red represents the degree of duplicated code therein.
I was already wondering.
If there is code duplication from one file to another one, their blocks will be connected by an edge.
Oh, I see duplicated code coming up.
We don't want that.
Oh, what happened here? A big, deeply red block shows up.
I was surprised myself when I saw it first. This is a third-party component. One of our developers has added it to our codebase. Interestingly, it is the one that computes the animations we are just watching. As you can see from its edges, the code duplication remains completely internal. The developer should have put it into a code library or assembly rather than in our source code folders. That is why we have later removed it from our codebase again. Without this animation, I would have probably not seen this problem.
I hope the developer has not violated any license.
Glad you asked. No, it was perfectly okay, but nevertheless, this component should never have been in our code but just be used as a library. Okay, I hope you've got a few interesting insights.
Yes, indeed. The Code Cities made many things very obvious to me. I will tell my friends about these cool Code Cities.
If they want to learn more about our Code Cities, please direct them to our website, c.uni-bremen.de. They can get more information and will also find our publications on this subject. By the way, our project is publicly available on GitHub too.
Nice. I still have a question though. Who is this lady here? You haven't introduced her to me.
Oh, sorry, I forgot. This is our personal assistant. She is here to help. You can ask her questions.
Amazing. May I try?
Of course.
Okay, C, tell me more about the project.
C4 Software Engineering Experience is a research project supporting distributed teams. It enables developers to meet in virtual room to take a look at their programs visualized as code cities. You should see it for yourself.
Many thanks. This was a wonderful experience. I learned so much. I will immediately get back to my code and make my changes. I am really looking forward to see my updates in a code city again.
It was a pleasure to have you here today, Sarah. I wish you a great day. See you soon again.
Bye-bye for now. I will soon be back.
See you.
See you.